Force. Now we're doing combinations part 1 and part 2 today, so separate videos, but combinations is the other half of permutations combinations, so that's kind of our other chunk. Remember we said permutation order is important, so then what would you assume for combination? It's not, exactly, and so that's what we're going to talk about today and how they differ. Okay, in the calculator it's in the same location, math probability it's NCR, combinations of C, NPR is permutation. Okay, so you guys know that in the calculator at least. Okay. As part of the grade 12 English course, students are required to read the following 3 books in a 3-month period: The Grapes of Wrath, The Wars, and The Bean Trees. Due to previous late returns, Steve is only allowed to sign out 1 English book from the school library per month. List all the different orders in which he could sign out 3 books. So it's a little tedious, but he can only do GWB, GBW, WGB, WBG, and then the BGW and BWG. So 6, which we also know is 3 factorial, right? 3 times 2 times 1. Okay, so we get all that stuff calculated. Okay, Tariq's allowed to sign out all 3 books at the same time. How many different ways can he do that? 1. If you check them all out, they're all out. The order doesn't matter of how you do that. Okay, the order doesn't matter of how you do that. That makes sense? Because if he can check all 3, it doesn't matter the order he picks them because he's getting all 3 of them checked out. Okay? All right. Okay? All right. Part A is an example of permutation where the order is important. Part B is an example of a combination. So here's the point. Okay? Here's the point. Here's the order matters because he's talking about he has to select them in a specific order because he's got limitations. Part 2, he can check out all 3 at the same time. It does not matter the order which he receives all 3 because he'll have all 3. Okay? So these are the examples that differentiate between combination and permutation. Okay? There's some better examples in this one if you still don't get it. Part A, a selection of a set of elements in which order of selection is not important is called our combination. So if order doesn't matter, we're thinking combination. Okay? Suppose the students in Part 1 were required to read only 2 of the books. Complete the table to show the number of ways in which Steve and Tariq could do this. Okay, if they're only required to do 2, then it could just be The Wars. I'll just put the Bean Trees here. The Bean Trees. The Grapes of Wrath. And then the Bean Trees. The Wars. Okay, so we just completed because they're right here. You have Grapes of Wrath, so there's 6 again, right? If you're doing 2. Okay, so now Tariq's is a little bit different now because he's not selecting all of them now. So there is more than 1 that he can select. Okay, so he's doing 2 at a time. He's not going to check out all 3. He's going to check out 2 at a time. So what he can do he can do Grapes of Wrath and the Wars. Grapes of Wrath, I'm just going to abbreviate. Grapes of Wrath and the Bean Trees. And then the Wars and the Bean Trees. So the point is, as you can kind of see, this right here, let's see. Grapes of Wrath. The Wars, the Grapes of Wrath. Right here. See this and this? Those are really the same thing, right? They're just reversed. And so the permutation is double counting that. But we don't care the order read. Then we have to read 2 of them. So that's why this situation, the permutations aren't helpful. Okay, same thing here. So Grapes of Wrath and the Wars. Where's that here? Oh, it's right here. That's why. Okay, so you can see they're all paired on the left. The right is just simply the combinations of 2. Okay, combination. So it says complete the following statement. The number of combinations is equal to the number of permutations divided by. Okay, so it's the number of permutations divided by 2. So you can see we had 6, then we had 3. So we had 6 here when I wrote them out, and we had 3. So you can see it's divided by 2, or 2 factorial we're going to figure out. Okay. It's part of the formula they're going to give you here in a second. All right, so again, one more time, permutations and arrangement of elements which the order is and needs to be taken into account. So the order matters. Combination selection where the order is not taken into account, not important. Okay, so going through this here, a little investigation. So we're looking at the two different options again. 5 students, Al, Byron, Colin, Dave, Eric, take part in a cross-country race to represent their school. Suppose the winner of the race wins $50, the runner gets 25, third place gets 10. The table below shows all the possible ways in which the 3 prizes could be awarded to 5 participants. Okay, A for Al, B for Byron, C for Colin, D for Dave, and E for Eric. So here's all the different top 3 finishes possible. Okay, all the way across. Is this an example of permutation or combination? Right, and what's the giveaway in the problem that makes it matter? Kind of, what? First, second, and third. First and second and third is different. So if I take 3 people, the order then matters because they get different money for first. First, second, third are different places. So the order which they come in is important. So that makes this permutation. Okay, so as an example, it's a permutation. Okay, how many ways can they be awarded the 3 prizes? This is where we simply would go 5 people. How many ways can we get groups of 3? Right, 5 permutation 3. So 5 people racing. How many different ways can I get groups of 3? That's 5p3. And you do that, you should get 60. So there's 60 ways they could finish. Because first, second, and third is important. That makes the order important. Nope, because you can say all the possible ways for combination, but combination takes out the repeated ones. But the key is first, second, and third identifies an order. So order is important for permutation. That's the giveaway. Okay. Now, second part B, it says for participating in the cross-country race, the school has been awarded 3 places at a running clinic. The school coach decided to select 3 lucky students for whom to take part in the cross-country race. So here's an example. It doesn't matter who gets selected first or second. They're selected to do the same job, right? They both get to be lucky. It's just like if I said I'm going to select 5 of you to help with the grade 5's math test or something, I don't know, whatever. The order that I select you doesn't matter. It's the 5 it selects is what's important, right? So the order is irrelevant. This is a combination example. Okay, as an example of permutation combination, this is a combination. How many ways are there to select 3 students? So what you would do here is you would do, how many people do we have total? 5 again? Yeah, is it 5? Okay, so then it'd be 5C3. Okay, which is 10, correct. And the reason it's 10 is because, again, what they're showing you here, and this is really cool, how this lined up. These combinations is all the same result. ABC, ACB, BAC, those are the same 3 people that got lucky. Right, and so the combination eliminates, this is one group. That's one option. And so see, it's 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why it's 10 combinations. Exactly. The order is not important of how those 3 people are selected. Exactly. Okay, any questions? Okay, so let's complete the following here, and we'll get to some examples. The number of combinations equal to the number of permutations divided by 6, which is factorial 3. So this one we were selecting 3, right? Last one we were selecting 2. Okay, so you divide by that factorial is what happens, the total. So this was 60 divided by 6. Where does the 6 come from? Stay with me. Where does 6 come from? No. 3 factorial. Sorry. We're doing the permutation divided by the factorial of 3. Right, the group's 3. The last group was 2 divided by 2 factorial. It's going to be right here in the formula. So they're just trying to show you that the formula's coming. Here's the formula. Okay, combination is very similar. Combination is very similar to permutation, right? Because permutation is that. right? The only thing we add is we divide by r factorial. So we divide by the selection amount. Factorial. That's what r is. R is your selection, n's your total, what you're choosing from. So I have 20 people, 3 of them I'm going to choose to stay in for lunch, okay? 3 factorial is the r. Okay? So this is your NCR formula. This right here is what your calculator is calculating when you do NCR. Okay? N total number, R what you're selecting. Any questions? What? Good? Okay. Example 1. Let's do an example here. Okay, 3 students from a class of 10 are to be chosen to go on a school trip. How many ways can they be selected? Write the answer in factorial notation and evaluate. Confirm the answer using your calculator. So this is clearly a combination because it doesn't matter the order they're selected. They're either going or they're not. Okay? So we have 10CR. Whoops, not R. It's 10C3. Which we can put in that formula there. So it's going to be 10 factorial over 7 factorial, 3 factorial. Okay, y is 7, 10 minus 3, okay, and then r, 3 factorial. 120 combinations to pick 3 people from your group of 10. I shouldn't say. So confirm the answer using NCR key. So you put your calculator, guys, you'll confirm it's 120. Okay, you'll confirm it's 120. All right, a couple more here. All right, let's figure out how to win the lottery. To win Lotto 649, a person must correctly select 6 numbers between 1 to 49. Jasper selected 6 numbers from the birth dates of his family, 3, 7, 9, 11, 20, and 29. How many different selections of numbers could he have made? So what you're saying is he's using these numbers, okay? He's using those numbers just because that's people's birth dates. If you don't know how Lotto works, no matter how you buy them, the order doesn't matter because they always put them in order for you. So like if you submit like you want, let's just say he colored in 29. 29 is always going to be the last one because it's the highest. Right, you can't pick the same number twice, and they always put them in numerical order. So as they're drawn, they come out like they'll be numerical order. So if an 8 comes, you still hit the 8, right? So, but anyway, so this is kind of where people figure out the lottery is really impossible, is that numbers between 1 and 49, that means you have 49 numbers to choose from. Choose 6. Right? 49, choose 6. So you just have a nice, smooth, easy 1 in 13 million chance. Almost 14 million. Yeah. So then think about, like Powerball in the U.S., the one that gets like the 380 million a lot. Well, the reason it gets so high is because people keep buying it, trying to win it. Well, they go up to 75. So if you do 75, choose 6. Then think about, you can go see what that is, but it's going to be bigger than 13 million.
But that's like 2 people in Yeah, it's like 2 people in
Yeah.
That's
Right.
That's 2 people. So true. That's 2
Yeah.
people in Canada. Oh, wait.
Right. So I think it was Aiden that said earlier his plans to win the lottery. Just, I don't know. All right. Okay. Well, yeah. The Athletic Council decides a form a subcommittee of 7 council members to look at how funds are raised should be spent on sports activities in the school. There are 15 athletic council members, 9 male and 6 female. The subcommittee must consist of exactly 3 female. Determine the number of ways of selecting the females. So how many different ways can you choose 3 females? Well, how many females are there? So this is, order doesn't matter, females to females, so it's 6, 3. So if you have to have 3 females, then how many males do you have to have? Because they're selecting how many? 7. So that means we need 4 males, so 9C4. And so then, what do you think we do? So then what's the total ways you can choose the whole committee? What are we going to do to finish that off? Not add, multiply, right? Because it's options times options, right? Because it's a tree, the tree diagram. So it's these multiplied. So I would just put I times part 2 multiplied. Okay, which is 2520. So this is 2520, this is 126, this was 20. Okay. And how many ways can a subcommittee be selected if Bruce, the football coach, must be included? So what does that change?
Fish or friends, hot food.
Huh?
Bruce.
Great. So, yes. Okay, what changes? The girls doesn't change. It's still 6 choosing 3. What changes with the boys? 1 less. Because Bruce is automatically in, so that's 1 less boy to choose from and 1 less you need because you're having a boy locked in. So you went from 9 choices to 8, and we don't need 4 anymore. We just need 3 because Bruce is already there. Okay? When you do that, you get 1120. 1120. Okay, one more example for this one, and then we'll move on. Okay, so standard deck. Okay, a lot of the things you're going to see, guys, when it comes to diploma SAT, they like to use card questions. Okay, so a couple of things you do need to be familiar with cards. Cards are 52 in a deck. Each suit has 13 of each. Okay, stuff like that. Knowing those, when I was teaching last year Hawaii, for everybody, people don't know deck of cards. That was kind of weird. Okay, but deck of cards is very common. Okay, so they kind of give you this here. So 4 suits, 13 cards. 2 suits are black, 2 suits are red. Face cards are considered Jack, Queen, and King. Poker is a card game played from a 52 deck of cards. 52 card deck, I mean. How many different 5-card poker hands are possible? And what's interesting about this is that a royal flush of 10 Jack, Queen, King of hearts is 1 in this amount, right? Which is kind of interesting. So how would you figure this out? Well, the order of them doesn't matter. If you have a royal flush, you have a royal flush. Okay? If I get dealt the Jack of hearts, then the King, then the Ace, then the Jack or 10, whatever. It doesn't matter when I'm dealt them. It's a royal flush. So 52C5 is how you figure out the odds of getting a royal flush, which is just another nice, easy, should be attainable 2.6 million almost. So that means to get a royal flush of hearts would be 1 out of that. Yeah, people have got it before. I've got a straight flush to the 6 before, which is still pretty rare. A lot of times they have bonuses for if you royal flush. Depends on the casinos. But yeah. Okay, and how many of the hands will there be all diamonds? So how do we figure this out? And how many hands will there be all diamonds? So just a flush. So you're doing 13C5 because there's 13 diamonds to choose 5 from. Okay. So it says in how many hands will there be all diamonds? So we're going to do, yeah, so they're just calculating like your chance to select diamonds of the diamonds, I guess. Because there's 13 diamonds to choose from to get 5. So like you would have to put that over like this in terms of a flush to get your chance to do it. They're just saying how many different ways can there be all diamonds. Okay, so let me say it again. Here's the difference. This one simply said how many different 5-card poker hands are possible. That's it. This says how many different hands will there be all diamonds. So what you got to do is figure out how many combinations of all diamonds are possible. So 13 diamonds there are. How many ways can I get 5 of them? That's the possible ways. That's not a percentage or like a, it's not a probability. To make it a probability, we'd put it over this. So that'd be how many ways you can get a flush. Okay, so 13 to the 5 is 1287. 4 black cards and 1 red card. So we have 2 things here. How many black cards are there? 4. Well, we want 4 of them, yes. How many total black cards are there? 26, choose 4, times 26, choose 1. Okay, we want 26 black cards, we're going to choose 4 of them. We want 26 red cards, we're going to choose 1 of them. We multiply those for 388,700. Math probability, just like we did with, same as permutations. NCR is right below the MPR. Okay. So 3 kings and 2 queens. Yep. So this is interesting because this is a full house. It's a pretty kind of a rare hand. So if you think about it, the possibility of doing this is low. Like if the number's low. See how this is really high? Is this hand anything? 4 blacks and a red? It's nothing. That's what this is. You can get this 388,000. That's almost like a sixth of the time that'll happen, which is pretty common, right? Then over here, getting all diamonds, 1287. I mean, that's pretty rare. Flush doesn't happen a lot, okay? And then you come over here, 3 kings, 2 queens, a full house. That's a big deal. That one's like even smaller. It's 4C3 because there's only 4 kings to choose from 3, and then there's 4 choose 2 for queens, 24. So 24 out of 2 million, okay, to get that specific full house. Now, it's that specific full house, not a full house in general, but that specific one. 4C2, 4C2, yeah. Sorry, 4C2. Okay, 3 kings. So now they're completing. So what they did here is this was 5 cards, this is 5 cards, this is 5 cards. You're not going to just get dealt 3 cards, right? So you need to fill in the other 2. So what you have to do on this is you have to go, okay, I know it's 4C3 for the kings. What's it for the other 2 cards? Not 52 because we have the 4 kings pulled out, right? 48C2. That represents the 2 random cards. Well, it says the probability in 3 kings. These have to not be kings. Because if you get the 4th king, that'd be 4 kings. Right. So it's kings, no kings. So that would be 4512. Okay. What's that? Sure. Okay. 4C4. And then 48C1. That's 48. Getting 4 of a kind is much harder. See, that's a less number of chances. That's more. So it's, yeah, you see 3 of a kind is definitely easier than 4 of a kind. Okay, and 5 cards of the same suit called the flush. So we want all 5 cards to be the same suit. So this would be essentially what we did here, except for we don't care if it's diamonds or if it's spades or clubs. So it is it's this one we did, and then what? Times by 4. Okay, because it can be either suit. So, because we did for diamonds, that one's all 4 suits, so we just times it by 4 to get the total possibilities for that. 5, 1, what's that? Oh, C5, yeah, thank you. C5, C5. We're not choosing 4 cards. Thank you. Erase that one there so we make sure we get that. 13C, that's awful too. Let's erase that. Okay, let's try it over here. 13C5. All right. Okay, that's it for the first one.